Let W be the amount of water in gallons in a bathtub at time t in minutes. What are the meaning and units of the derivative of W with respect to t? So when I look at this, I say to myself that the numerator is the change in W. So W is in terms of gallons. And then the denominator is the change in T, and T is in minutes. So then when I think of dW dt, that's gallons per minute as far as the units of measure is concerned. Now, the meaning of this is the rate at which the water, all right, let's say the gallons of water change each minute. So I got the word gallons, which is changing for every minute of time. So gallons per minute, and it's a rate because derivative is a rate of change. Now B, suppose the bathtub is full of water. So imagine this, you have a bathtub full of water sitting in front of you at time t sub 0. So that's how much water is in there. The water's full at the initial amount of time when you start this experiment. So that the water level at t sub 0 is greater than 0. Or the number of gallons is greater than 0. Subsequently, at time t sub p greater than t sub 0. So this is a time that's later than the initial time. Doesn't matter when, it's just later. The plug is pulled. So is dW dt positive, negative, or 0? So this is between the time initially and then when the plug is pulled. So the water level isn't changing at all, or the amount of water isn't changing at all. So the rate at which the gallons per minute is changing is 0 because nothing's happening. After the plug is pulled, but before the tub is empty. So the number of gallons in the tub, so I pull the plug, and what happens to the number of gallons? It goes down the drain, the number of gallons decreases. So that means that your rate of change in gallons per minute has to be less than 0 because it's decreasing. And then lastly down here, when all the water has drained from the tub. So that's saying, okay, now all the water, the plug is pulled, all the water is gone, and then what happens to the rate after that? So, well, there's no water in there, and there's no change in water level, so we're back to 0 again.